welcome back to our channel. So in the previous session we have covered the data structure concept, that is a linked list. So in that we have seen the two operations, the insertion and the deletion in all the three cases. So for single linked list, double linked list and circular linked list. So in today's session let us see about the another linear data structure, stacks. So first point, it is a linear data structure. So stack is a linear data structure. So linear data structure means all the elements are arranged in a sequential manner. So elements are arranged in sequential. Right. Then it follows the last in first out mechanism. It follows LIFO, that is last in first out mechanism. So here the name itself indicates whatever the element inserted into that stack last, that should be removed first. So last in first out, whatever the element is inserted at the last, that should be removed first. Right, last in first out. The best example for this stack is arranging the plates in a tray. Plates in a tray, or coins, arranging the coins. Arranging the coins or books. So whatever it may be, anything we can consider it as an example, right? So consider these plates, arrange the plates. So if you consider a tray and if you start inserting the plates, so the first plate will be here, and the second plate will be on the above of the first plate. So the second plate will be placed on the above of the first plate. Third plate will be inserted here. Fourth plate will be inserted here. 1, 2, 3 and 4. Right? Now a tray consists of 4 plates. So if you want to remove the plate, which plate should be removed first? The fourth plate should be removed first. We can't remove the first plate. The fourth plate should be removed first. That means whatever the element which is inserted last, because in these 4 plates, what is the element which is inserted in the last? That is 4. Plate 4. So that should be out. That means that element should be removed first. Right? So see. Here, it is having 2 operations mainly. One is push operation, another one is pop operation. Push and pop, 2 operations. Push operation means inserting an element. Pop operation means deleting an element. Right? Right. Inserting an element into the stack, deleting an element from the stack. That is pop. These 2 operations can be applied for a stack. Next, here both the insertion and the deletion can be performed on only one side, that is at the top of the stack. So if you want to insert an element to the existing stack, we have to place that element at the top of the stack. And if you want to delete the element, you have to delete the element from the top of the stack. So either insertion or the deletion, both the operations can be performed on only a single side, that is top. So we can use a TOP, top, is it? top of stack. So where can be performed both push and pop operations. In the top of the stack, both push and pop operations can be performed. Initially, if there are no elements in the stack, this top is equal to -1. If the top is equal to -1, initialization, right? Initial value of the top. So if the top is -1, that implies the stack is empty. No element is presented in the stack. And if you are trying to insert an element into the stack, first we have to update the top and then we have to insert the element. Similarly, if you want to delete the element from the stack, you have to delete the element from the stack and you have to update the top, right? You have to decrement the top, right? So now this stack can be implemented in two ways. I'll write here. So implemented in two ways. What are they? First one, using arrays. Second one, using linked list. Right. So two ways we can implement this stack by using the arrays and linked list. So in today's session we will see the operations of push and pop. So these will not change. Okay. Only the implementation will be changed, but everything is same for both the cases. If you are implementing stack using arrays, the same thing will be applied. If you are implementing the stack using linked list, the same things will be applied, right? So the only difference is implementation part. So in the arrays we need to take the maximum number of elements prior to the insertion or a deletion, right? We need to take the size of the array. So coming to the linked list, we need not take the size of the array first, because size of the stack, because there we will use dynamic memory allocation, right? Here we are using the static memory, right? That means before starting the stack itself, before inserting the element into a stack itself, we have to decide the size of the stack. Okay, then let us see the push and pop operations of stack, which is implemented by using arrays. So hope you understood this one, right? So it's a linear data structure. It follows the LIFO format, the mechanism, and two operations will be there, push and pop. Right. There are two more concepts. Just I will explain and then we will go with the operations. See. So while implementing the stack, we need to verify two conditions. That is overflow condition and underflow condition. So while implementing the stack either using arrays or a linked list, we need to check these two conditions, overflow condition and underflow condition. When this overflow condition will occur? When you are trying to insert an element into the stack already which is having the maximum elements, then this overflow will be occurred. For example, if stack consists of 5 elements, if you are trying to insert sixth element, into the stack which can hold only 5 elements, then this overflow condition will be occurred, right? That means this will be used in push operation. That means we need to check the condition while performing the push operation. So inserting an element to the stack which is already having maximum elements right. So this occurs when we are inserting an element to the stack which is already having the maximum elements. Then underflow condition. Underflow condition means the reverse. That means if you are trying to delete an element from the empty stack, so there are no elements in the stack, but still you are supposed to remove an element from the stack, right? So then this condition will be occurred. That means deleting an element from the stack, from the empty stack. Simply we can write from the empty stack. Then automatically this condition will be occurred, underflow. So that means this condition is to be checked at pop operation. In the push operation we have to check this one. In the pop operation we have to check this one. Right. Now let us go with the direct functions push and pop. Right. So implementation of a stack using arrays. So we will go with the arrays, right? Right. So in this we need to give the size of the stack before starting the insertion, right? So static memory allocation. So we need to give the size of the array. Let it be 10. That means maximum 10 elements can be inserted. And initially the top is equal to -1. That means let us take here right. So let us consider here top is equal to -1. Right. So coming to the push operation, first we need to read the element because this is an insertion. Push means insertion. So read an element. So scanf %d. Let us read a numerical element, right? So we are reading an element. So we need to insert this element into the stack. So we need to declare the stack also. We need to declare stack also. Stack, it's an array. It's an array of size 10. Stack is an array of size 10. So in the push operation we need to check the overflow condition. So if top is equal to size -1. So here top is equal to -1 initially before inserting any element. That means 0 elements. Size is 10. So size is 10 means the index values will be from 0 to 9. That means size -1. So for every insertion we need to update the top of the stack. So if the top of the stack is equal to size -1, that implies the complete elements are inserted into the stack. That means the stack is full. So if this condition is true, we can print overflow, or simply we can print stack is full. Else, that means if this condition is fails, that means there is a vacancy in the stack to hold the element. Then we need to increment the top first, because initially top is -1 and after inserting the element top will be at 0. So first we have to update the top. So top plus. So we need to update the top so that the top will be updated to the next position. Then we have to insert the element at that position. So here, if you, let us take the position top plus plus, top is equal to 0. So here it is, top is equal to 0. Now we need to store the element in this position. So then stack of top is equal to element. Stack of top, that means stack of 0 is equal to element. So let it be 10. The 10 will be inserted here. Right? So close the braces. So this is a simple push operation. Coming to the second iteration, right? So again, if you apply this push operation, again it will read an element. Let it be 20. Top is equal to size minus 1. Top is 0 is equal to 9. Condition fails. Again, top plus plus. Now top is equal to 1. Right? Stack of top, stack of 1 is equal to 20. So 20 will be inserted here. Again, if you again call the push operation, 30. So top means 1. 1 is equal to 9. Again false. So again else condition. Top plus plus. Initially now top is equal to 1. Top plus plus means top is equal to 2. So obviously stack of 2 is equal to element 30. So 30 will be inserted here. Okay, so hope you understood this one, right? So initially first we have to check the overflow condition. If it fails, then we have to increment the top and then we have to insert the element into the stack. And the only disadvantage of this implementation is, before starting the implementation, we need to specify the size of the stack. So beyond that size, an element cannot be inserted into the stack. That's the main drawback of implementing the stacks using arrays, right? So coming to the linked list, there we will use the dynamic memory allocation, so there is no restriction to the size of the stack, right? Now, so hope you understood this push operation. Now we will move with the pop operation. See, after inserting the elements, the top is assigned to 2, right? Now pop operation. Pop means deleting an element. So before deleting, we need to check the underflow condition. That means whether we are supposed to trying to delete the element from the empty stack or not. So for that we need to check the underflow condition. So if top is equal to minus 1, so obviously if you are not inserting any element, then the top is always initialized to minus 1. If you insert an element, automatically the top must be get updated, so top will not be equal to minus 1, right? So if top is equal to minus 1, we can say that printf underflow. So if it fails, that means else condition. If it fails, then we have to remove the element which is available at the top, right? So here we have to remove the 30 element. We can't remove the 20 and 10 until you remove the 30, right? So that's why else, what is the element to be removed? So element is equal to stack of top. That means here the removing element is stack of top. That means stack of 2. Stack of 2 means 30. So that element will be removed, and after removing the element, this top should be updated. So top minus minus. So automatically top is equal to 2. After applying this pop operation, top will be 1. Right? That's all. This is a simple pop operation. Okay, a simple pop operation. Again, now top is equal to 1. Again, repeat if you want to again remove the pop, I mean if you again apply the pop operation, then top is equal to minus 1, 1 is equal to minus 1, false. So else the element is equal to stack of 1, 20. In the second thing, if you want to again apply this pop operation, 20 element will be deleted and top minus minus, now it will be 0 at 0. Again if you apply this top, if you call this pop operation, next 0 is equal to minus 1, again it is false, so element is equal to stack of 0, so element is equal to 10 and top minus minus, so it will be minus 1. Now automatically the elements of the stack is, see, after applying the pop 3 times, the top is equal to minus 1. Again if you are applying the top, I mean pop operation, the top is equal to minus 1, that means minus 1 is equal to minus 1. It's true because there is no element available in the stack. So that's why it will be printed underflow. Right? So hope you understood this pop operation also. Simple operations. First you have to delete an element and then we have to reduce the top. That means update the top, decrement the top. Right. Next, how to display the elements of a stack. Display function. We will see the display function also. If a stack contains 4 elements, so top is equal to 0, 1, 2, 3. So top is equal to 3 now. Top is equal to 3 now. Right? So display function. How to display the elements of a stack. Simple. We need to check whether it is an empty stack or not. So if top not equal to minus 1, if it is not equal to minus 1, automatically that implies there is a, I mean there are elements available in stack. Then use a for loop for I is equal to top, that means 3, I greater than or equal to 0, until top is equal to 0. I minus minus. I minus minus. Every time we have to decrement because we are assigning I with the top element. Here we can print the element. Printf percentage %d stack of I. Stack of I. Close. Else, if this condition fails, not equal to minus 1, that means if it is equal to minus 1, we can simply write printf, we can simply write empty stack. Empty stack. Right? Let us trace it. So initially here top is equal to 3 now. Top is equal to 3. In the first iteration, top not equal to minus 1, right? Top not equal to minus 1. So 3 not equal to minus 1. True. So for I is equal to top, I is equal to 3. First iteration, I greater than or equal to 0. So 3 greater than or equal to 0, condition true. Then stack of I. So stack of 3 will be printed. That is 40 will be printed. Next, I minus minus. Now I is equal to 2. Then again 2 greater than or equal to 0. True. Then print stack of 2, which is 30. And again I decremented. Now I is equal to 1. 1 greater than or equal to 0. You need to print stack of 1, which is 20. Right? Next I is decremented. Now I is equal to 0. So 0 greater than or equal to 0. Here we are using the is equal to also. So that's why still the condition is true. So stack is stack of 0. That is 10 will be printed. Again I minus minus. I is equal to minus 1. Minus 1 greater than or equal to 0. Condition fails. It come out from the loop and it ends the display function. Right? So hope you understood this one. Simple logic for push operation, pop and display operation. Right? So implementing the stack using arrays, we will be having two operations, push and pop. Insertion push operation, for deletion pop operation. So while inserting an element into the stack, before we have to check the overflow condition, and while decrementing an element from the stack, we need to check the underflow condition, right? So these three operations. So let us stop here. So the main drawback of using arrays is the static memory. So before we have to declare the size of the array, and if you want to increase the size of the array, it's not possible here unless you use the dynamic memory allocation, where we will implement in linked list, right? So hope you understood this one. So stack and the operations of a stack and the implementation of a stack using arrays, right? If you are having any doubts regarding this session, feel free to post your doubts in the comment section, so that definitely I will try to clarify all your doubts. And if you really understood my sessions, like my sessions, share my sessions with your friends, and don't forget to subscribe to our channel. Thanks for listening. Thank you very much.